In this video we want to consider situations where we might have variable forces at play rather than constant forces. So a lot of the situations we've dealt with, the force and the acceleration in the system are constant. But now we want to say, what if there's variation going on? And that variation could be expressed as a variable of t, or a variable of v, or a variable of x, or so on. So what we're going to be dealing with here is generally we can solve these problems by using our knowledge that force, the resultant net force, is mass times acceleration, along with the appropriate expression for acceleration. What do I mean by that? Well, remember now that we've got four different expressions for acceleration: dv dt, d2x dt squared, v dv dx, and ddx of a half v squared. And remember that those are all on your formula sheet, so you don't need to remember those off by heart. But because our force might be expressed as a variable in, the variable t, or the variable v, or the variable x, might depend on which of these is most appropriate for us. So let's have a look at what I mean by that by considering this example here. From exercise 14I, we've got a particle of mass 5 kilograms moving in a straight line. At time t seconds, its position relative to a fixed origin is x meters, and its velocity is v meters per second. Okay, so t is time in seconds, v is velocity in meters per second, x is meters from a fixed origin. We're going to have a look at part B. So these are separate problems related to that information. Part B says, if the resultant force acting is 10 plus 5x, and v equals 4 when x equals 0, find v when x equals 4. Alright, so let's think about what we're being told here. We're being given the information that the force is varying with the displacement or the position of this object relative to the origin, isn't it? So basically this is saying, as this gets further and further from the origin, the force is increasing because it's 10 plus 5 times its position relative to the origin. So it's varying. Alright, now we're trying to find an expression that relates velocity and position, aren't we? Because that's what we've got here, and what we're trying to find is all stuff to do with the relationship between velocity and acceleration. So first thing I'd be saying here is, well, therefore mass times acceleration is 10 plus 5x, and we know the mass is 5 kilograms. So we could simplify this just by dividing by 5. We could say, what's that, 2 plus x. So the acceleration is equal to 2 plus x, but we need something that relates velocity and position. Hopefully you can see that these first ones here, they relate velocity with time and position with time. They're not going to help us, so it's going to be one of these ones down here. And I'm going to try using this final one here. I'm going to say, therefore, ddx of a half v squared equals 2 plus x. So therefore, let's say, well, if we were then to integrate both sides, or if that's the derivative of a half v squared, then a half v squared must be the integral of 2 plus x with respect to x. So we're fine with that step. If the derivative with respect to x of this is that, then this must be the integral with respect to x of that side there. And that's going to be fairly easy to complete, isn't it? So that's 2x plus x squared over 2 plus c. Now, to work out c, we could use, so what are we given? We're given the bit of information here is that v equals 4 when x equals 0. So let's substitute that in. So therefore a half times 4 squared equals, well, when x is 0, all we're left with on that side is c. So what's that? C is 8. So therefore half v squared is equal to 2x plus x squared over 2 plus 8, and we're trying to find velocity when x equals 4. So we're going to get half v squared is 2 times 4 plus 4 squared over 2 plus 8, so it's that 8 plus another 8 plus another 8 is equal to 24. Is that right? So therefore v squared will be double that, and so we're trying to find the velocity. Therefore velocity is the square root of that. What's the square root of 48 is 16 times 3, isn't it? So square root of 48 we could write as 4 root 3 meters per second. Now in this situation we could have said here, well, is it plus or minus the square root of 48? But I think what we'll find here, because it's got a positive velocity initially, that means it's going to be moving in a positive direction, which means x is going to be positive, and that means that the acceleration is always going to be positive. And so basically, because of the relationship between force here and its starting conditions, it's never going to have a negative velocity. So we could say ignore negative as v is greater than 0 for all x.